Welcome back to the Graphing Motion. You've already submitted your predictions. Now it is time to score your work. So let's take a look at what we've already done. This was just the introduction video. Okay, so here is the first one, and this was the example that I showed you earlier, and it's just a train pushing a fan cart at a constant rate. And when we see that train go by, it's a nice little flat sloped line, and the velocity stays pretty consistent even though it's kind of bumping along. So here's where you put that onto your piece of paper and correct. So we already did this though in the first one. So let's zoom in on the second one. Here we have demo 2, and demo 2 is going to produce an acceleration like what is already on the computer screen. So let it go, Mr. Kent. There it is, in a nice curve. And on the velocity time graph, since it's always speeding up, it's going to produce a line that is always getting faster on the velocity time graph. The third demonstration goes up the ramp and slows down while it's going up the ramp. So here's Mr. Kent. Nice catch, showing us how it works. And as we look at the computer screen, it shows a curve that falls off at the top because it's slowing down to a stop. And the velocity time graph is just a line where it started out fast and goes straight down to 0. Check your work. And finally, we move along to the fourth one, where it went up the ramp and back down. And here is Mr. Kent showing again. It goes up and down, up and down. Now let's take a look at the graph, and you can see it produces a beautiful curve up and curve down, a combination of the two previous demonstrations. But this is surprising. The velocity time graph points down but goes through 0 and goes back in the negative direction because it was speeding up in the negative direction. That is tough. Did you get that? Maybe you got the distance versus time as a nice curve, but the speed one was a tough one. All right, so now that we're done, put your score on your paper and turn it in.